Hello everyone, welcome to my channel Dr. Techfire. In this video, we are going to start with our new series of class 12 chemistry. So first chapter of chemistry is solid state. Starting with the introduction. Apart from liquid and gaseous states, solid state is a state of matter. Solids have strong intermolecular interactions and there are very few vacant spaces between atoms, ions, molecules. As a result, they have a predetermined shape and volume. As we all know from our class 10 that there are three states of matter: liquid, solid and gas. But in this chapter, we are only focusing on the solid state. Let's move further. What are the characteristic properties of solid? The following properties come under the category of solids. Solids have high density, low compressibility, and solids are rigid in nature. They have definite shape and volume. Now, coming to the classification of solids, on the basis of following parameter, solids are broadly classified as classification based on various properties and classification based on bonding present in building blocks. We will be seeing the classification based on various properties, but talking about the classification based on bonding, it is not in our syllabus. So we'll just talk it for 2 minutes about. And the classification based on bonding. The solids are classified on this criteria as ionic bonding, covalent bonding. In ionic bonding, there ions are present in which intermolecular forces occur. And in covalent bonding, we have the sharing of ions or atoms to attain a stable state. Now, on the basis of various properties, the solids can be classified as crystalline solids and amorphous solid. Amorphous solids have an uneven structure over long distances and lack sharp properties, whereas crystalline solids have a regular structure throughout the entire volume and sharp qualities. The table shows the many differences. These differences are asked in an examination, that is, differentiate between crystalline solids and amorphous solids. So first, differentiating them on the basis of their shape, crystalline solids have a long range order, whereas amorphous solids have a short range order. Crystalline solids tend to have definite melting points. Amorphous solids do not have a definite melting point. Then heat of fusion. Crystalline solids have a definite heat of fusion. Amorphous solids do not have a definite heat of fusion. Compressibility. Crystalline solids are rigid and incompressible, whereas amorphous solids may be compressed to some extent. Crystalline solids tend to break into two pieces with plane surfaces, whereas amorphous solids have irregular cleavage, that means they break into two pieces with irregular shapes. Crystalline solids are anisotropic, whereas amorphous solids are isotropic. Crystalline solids have interfacial angles, whereas amorphous solids do not have interfacial angles. When crystalline solid melts, there is a sudden change in their volume. On melting, there is no sudden change in the volume of amorphous solid. Crystalline solids possess symmetry, whereas amorphous solids do not possess any symmetry. Coming to the structure of crystalline solids. So what is crystal lattice and unit cell? The crystalline solid regular array of building pieces is known as crystal structure. And unit cell refers to the smallest component of a crystal lattice that can be repeated in all directions to form the full crystal lattice. Small spheres represent the atoms of ions or molecules in a unit cell. Variations in the following parameters produces several lattices. The edge along the three axes A, B and C, the interfacial angle, that is alpha, beta and gamma, and location of atoms with respect to other in crystal lattice. Density of cubic structure. By the following formula, the density of cubic crystal is given. Density of cubic crystals. By the following formula, the density of cubic crystal is given. Rho is equals to m into z upon a cube into Na, where z is the rank of unit cell, m is the molar mass of the solid, a is the edge length of unit cell, and Na is the Avogadro number. The volume of Z will depend on the type of unit cell. Now, voids and radius ratio. Voids are the empty spaces inside a sphere. The amount and shape of voids is determined by the unit cell and packing used. The radius ratio of a sphere that can be perfectly fit in the void into the radius of surrounding spheres is used to determine the size of void. This is written as R by R, that is small r by capital R. Then there are three types of voids. First is trigonal void, then tetrahedral void, then octahedral void. In trigonal void, it is a void formed of equal radii which touches each other. Here the radius ratio is 0.155. It is the smallest void whose coordination number is 3. Then tetrahedral void. It is formed by the contact of four spheres and is located in the center of tetrahedron formed by the contact of four spheres. The radius ratio of tetrahedral void is 0.225. Number of voids in FCC crystal is 8. Position at a distance is a root 3 by 4 from every corner. The coordination number of tetrahedral void is 4. Then octahedral void. Its radius ratio is 0.414 r. Number of voids in FCC crystal is 4. Positions, body center and edge center. Its rank is 4, that is Z, which we have seen in the formula of density. Then the coordination number is 6. Now coming to the imperfections in solids, these imperfections are also known as defects. There are mainly two types of defects, stoichiometric and non-stoichiometric. Stoichiometric defects are classified as Schottky and Frenkel defect, whereas non-stoichiometric defects are classified as metal excess defect and metal deficiency defect. Now let us see all of them. Types of defects include the vacancy defect, Schottky defect as well as Frenkel defect in the stoichiometric defects. Vacancy. This type of defect occurs when the positions that should contain atoms or ions are vacant. Interstitial sites. These are sites located between regular positions. Sometimes atoms or ions may occupy these positions. Schottky defects. In ionic solids, it is a vacant defect. Electrical neutrality is maintained because the number of missing cations and anions is equal. The density of the substance is reduced as a result of this flow. Ionic compounds with almost identical cation and anion sizes demonstrate the flow. Examples include KCl, NaCl, AgBr, etc. Then Frenkel defect. The smallest ion is relocated from its typical position to an interstitial region in ionic solids. At its original place, it causes a vacancy defect, and at new location, it causes the interstitial defect. Dislocation defect is another name for it. It has no effect on the solid's density. Ionic compounds with a considerable disparity in ion sizes are example of this defect. Then the non-stoichiometric defects include metal excess defect as well as metal deficiency defect, where metal excess defects is further classified as due to anionic vacancies. It is possible that the anion is absent from its lattice position, leaving an electron behind to keep the charge balanced. The F center is the electron containing site. They provide the crystal color. F stands for Farben-Center, which means color. This defect looks like Schottky defect and can be seen in crystals with Schottky defect. Examples include NaCl, KCl. Then, due to presence of extra cations in the interstitial site. This is the second type of metal excess defect. To maintain electrical neutrality, an additional cation may be present in one interstitial site while an electron is present in another interstitial site. This is a flow that is similar to Frenkel defect and can be discovered in crystals with the Frenkel defect. Then at last, metal deficiency is metal deficiency defect. When metal has a fluctuating valency, this is a defect. FeO, for example, is generally found in compositions ranging from FeO 0.93 to FeO 0.96. Some +2 Fe cations are missing from FeO crystals, but the loss of positive charge is compensated for by the existence of the requisite amount of +3 Fe ions. That's all for the chapter 1 of class 12. Thank you guys for watching. Do not forget to like, subscribe and share, and do comment for any further queries.